Welcome to the Vojo Health podcast. Let me first introduce you. So, this is Dr. Nicholas Norwitz. He obtained his PhD at Oxford University in just 2 years. It's pretty impressive. We'll get to that later. And is now pursuing his medical doctorate at Harvard Medical School. So his research expertise is in ketosis and brain health. And he's also a co-author of a Mediterranean cookbook. So you've got a lot going on. And you're still pretty young. This is amazing. Tell us more about your health journey and how you got into nutrition research in the first place.
Yeah, well, first of all, thanks for having me so much, Ellie. I'm really looking forward to this conversation. With respect to my health journey and food is medicine, to be perfectly honest, I used to think it was a little bit fluffy. I know it gets that reputation. How could food be medicine, right? And so it was something I took for granted until, and I won't go into detail with my health saga, not a woe is me podcast. Let's get into some science and nerd out a bit. But I was a pretty healthy kid, at least on the surface. My entire youth never struggled with weight or any real severe illnesses throughout my childhood and high school. I was very athletic, very lean, ate a pretty healthy standard American diet, as in I was very aware of the food pyramid in my plate, ate my 5 a day, etc., etc. I really loved running and athletics, but then things started to fall apart for me when I was at the very end of high school going into college, when I developed a degenerative bone condition of unknown origin. So I was running and my bones started to break down. I ended up developing osteoporosis out of nowhere, which was quite weird for me and hard for me because I thought I'd be running for the rest of my life. It was something that I just enjoyed and part of my everyday. And nobody could really tell me why that was going on. So that was a question mark. And just as I was getting over it emotionally, I was struck with strike two, which was ulcerative colitis, an inflammatory bowel disease. So Crohn's and colitis are ulcerative colitis are the two main inflammatory bowel diseases, and that, if you can imagine, it was even worse than I'm sure osteoporosis wasn't horrible day in and day out, but the colitis was. It really took away my social life and my enjoyment of food, which was, it's when you love, when you're a foodie and then you go from being able to eat everything in the kitchen sink, and I literally would eat anything. I had no food aversions. I was quite honestly one of those arrogant people and dismissive people who thought that gluten-free was just a fake thing, more or less. I mean, I knew about particular gluten sensitivities, but I wasn't that sensitive to it. And then I went to a place, I guess fate humbled me. I really could eat very little, and food became a terror. Socializing became really difficult just because you never know when a flare is going to strike. And then things hit a climax when I finished up my undergraduate studies and went to Oxford to do my PhD. Because within a few weeks of moving there, my health took a serious downturn. I had a terrible colitis flare, dropped a ton of weight, 20% of my body weight in a few weeks. And one night at 2 a.m., they had to rush me to an NHS hospital because of severe stomach pain, but it was incidentally noted my heart rate was in the 20s, which is kind of scary low. So they put me as an inpatient, actually in the palliative care ward, because they had nowhere else to put me, for 3 days. Where again, the etiology, the cause really of my low heart rate, as well as my colitis, as well as my osteoporosis, were just continued to be unknowns. And at that point, I was a little disillusioned, a little hopeless, and a little desperate. So I started to experiment with things, not because I had any expectation they would work, but just because I had no alternative. So I just started trying X, Y, and Z diets and found eventually a nutrition program that worked really well for me and just changed my life. Brought back my energy, brought back my mental clarity, made my colitis just disappear. Literally within a week. I had not been able to keep it in remission with any meds. And then when I did a particular dietary change, my colitis symptoms went away and my inflammation dropped to its lowest level ever. And I came off my meds and the inflammation just never came back. And it really just, gave me my life back. I was at a point, I guess I've gotten to that woe is me point, sorry, in the podcast now, that's a little meta, but I was at a point where I thought I had a lot of potential. I had the opportunity to get an Oxford PhD, go into Harvard to do my MD. I used to be an athlete and very active and happy and and just energetic, and I thought I was going to lose all of that to my health issues. By playing around with metabolic health and food as medicine, I recovered all of it and more, because now I have a self-determined purpose to make, I think, food as medicine and metabolic health part of standard of care, because I know how it would transform my life if it were pushed more as a primary care option. And since, having my experience, I've met literally hundreds of other people who have had similar experiences, and I see this motif over and over again, where people struggle with a chronic health disease in conventional care with drugs and procedures, and then they try something like food as medicine or metabolic medicine and discover it really works for them. And then sometimes become a little bit evangelical about it, which is maybe why we get these diet wars and these like little diet cults. But I think a lot of the time it actually comes from a good place where at least a certain population has found that it really transformed their life, and there's this frustrating concern because I know what it can do for other people. So that's my elevator pitch of myself and my story, and why I'm interested in food as medicine, which is not something I ever would have thought I would have said, say, 5 years ago.
Yeah, I mean, there's so many interesting things to dive into there. Most of the time today, I want to talk to you about a new paper that you've written, which is about Alzheimer's disease and genetics and precision nutrition, on like things we can do with our diet and lifestyle to work with Alzheimer's disease, especially in people with this increased risk. How did you transition from your own interest from your chronic illness, from colitis, to brain health?
Well, I had always been fascinated by the brain. I wanted originally to do a neuroscience major when I was in undergrad, and ended up transitioning to focus on cell biology. But I was always reading, like literally one summer I just read a neuroscience textbook for fun. Like, I'm so fascinated by the brain. I don't know how you can't be. The organ that makes us human beings, like, it's such a interesting black box. I've always been fascinated by it since I was an adolescent. And in complement to that, a wise mentor once told me that empathy in medicine is not actually necessarily about going through what your patient went through or what somebody else goes through, or just empathy as a person. It's being able to extrapolate from your own suffering what somebody else might be feeling. And I've suffered a little bit, and I try to use that to imagine what it might be like to suffer with other diseases. And there's no disease scarier to me that causes more suffering for individuals or their family members than Alzheimer's disease. To me, it's the scariest disease, compounded by the fact that it's one of the leading causes of death now. Not only does it destroy quality of life, but it's one of the leading causes of death, and the only top cause of death of the top 10 that doesn't have any effective treatment or cure. None whatsoever. And we don't really seem to be on track for doing that. I don't know if you're aware of some of the controversy that's come out very recently about, it's quite timely, the new Alzheimer's drug. There was a new Alzheimer's drug approved despite the fact that most members of the FDA advisory didn't want to approve it. Because there's really no evidence. So there have been we can get into that if you want, but there have been no effective pharmaceutical interventions for Alzheimer's disease, really. There's a little bit for symptomatic management, but the drug failure rate is, for symptomatic management, 99.7%. Pharmaceutical companies are pulling out because it's just such a money sink. And personally, I think that the avenues we're using to approach treating Alzheimer's disease right now are doomed to fail, which sounds pessimistic. But I actually think it's optimistic, because I think that there is more possibility than people realize for preventing it if we just take a different tact. Focused on full disease prevention, up until that point then maybe we have more advanced CRISPR technology or stem cell therapies where you can actually cure it. But I don't think Alzheimer's disease is a disease you can cure per se. I think it's a disease you need to prevent. Get into what I mean by that, but it really stems from the fact that this is a disease that starts 20, 30 years before symptoms develop. So if you start developing symptoms and then try to address it, the boulder's starting to roll down the hill already, and you can't really push it back up. Yeah,
and I guess that's a bit of a problem, right? Because, we talk about preventive healthcare, preventative nutrition. But the problem is that people don't put effort in until they have a problem. When they have a problem, that's when they start looking for solutions. And in my case, I'm very interested in this because my dad died of dementia, and I have the genes associated with Alzheimer's disease. So I'm 30. I'm not 30 yet. I'm almost 30. Still in my 20s, hanging on. And I'm already doing all of these things that I can do to prevent this disease, because I know the effect that it can have on people, and I do not want to go there. So, and I know my risk. So, there are things that can stimulate people to make those changes, but still, most of the time, we encounter the problem first, and then we think of how to solve it. What do we do about that?
And that's a very difficult question. I don't think, basically what you're saying is, how do you motivate people to, make sometimes difficult lifestyle changes, because any lifestyle change is difficult, to prevent something that they don't really understand the weight of, nor do they think it will happen to them. Like, everybody never thinks like, oh, I'm never going to get cancer, I'm never going to get Alzheimer's, I'm never going to get in a car crash until it happens. So it's like, putting on your seatbelt. We want to, push people to do it preventatively, and beyond just making it the social norm, like putting on a seatbelt. How do you do that? Well, I think that's difficult. I think one thing you can do is to find associated ways, like indirect ways, to sell people on interventions that will help prevent that disease. So one thing we can talk about is overall metabolic health and metabolic syndrome, which might be relevant to everyday, say, weight loss or cognitive sharpness, just feeling good throughout the day. And the interventions that would help with metabolic health in general are going to help prevent Alzheimer's disease. So you can find proxies like that. And this is a controversial one, things like, at least with Alzheimer's disease, genetic testing. I think you alluded to being at high risk for Alzheimer's disease, and I happen to know I'm at high risk too. I'm not sure if you're referring to the ApoE4 allele, but that's the most prominent genetic risk factor for Alzheimer's disease that about a quarter of people, 20 to 25% of people, carry, putting them at high risk, and about 2% carry 2 copies, which can increase your risk over tenfold on a population average. Now, I do think you can prevent it, but having that awareness is a huge motivating factor. That said, it's a big ethical conundrum, because right now, because of the ways studies are conducted, because we don't ever have true preventative Alzheimer's trials. We're never going to have data saying we know how to prevent Alzheimer's disease. So this allele remains, quote, like a non-actionable allele. People say, like, you can't do anything about it, so why test it? Why stress patients out? Well, it's true we don't have long-term clinical data showing that you can do a dietary intervention to prevent Alzheimer's disease, but that's because imagine trying to do a randomized controlled trial. It takes 30 years long with this specific dietary intervention. It will never, ever be done. And so, in my opinion, what you need to do is you need to have a bottom-up approach. Think about the mechanisms, what we can derive from understanding the biology, and then make a best guess based on a combination of population data, correlational data, and mechanistic data to say, this is what I want to do as an individual to help prevent this disease. And quite honestly, I don't know how you feel. It seems like you're someone who's of a similar opinion, but once you kind of get into nutrition science, and you don't have to be like a nutrition nerd to have this perspective, but once you get into it, you can start to appreciate how powerful focusing on metabolic health and food is for improving the way you feel and think and just are as a human being, such that food isn't just a gustatory pleasure, but an experimental one where you actually want to do these things, like, and become observant. Like, you can't help it. Like, when I eat this, how do I feel? And then you use that as data points to continually improve. It becomes quite a fun game. So I enjoy it. It's not a chore for me ever. I'm always doing like little self-experiments, and I think that's a mindset that anybody can achieve. And if you can achieve that, then you're always just going to be improving your health, which will help you prevent all chronic diseases, which I think share certain core pathologies, whether they be diabetes, cardiovascular disease, Alzheimer's. I think the interventions to prevent them are usually the same. So whatever your fear, just, you can find common interventions.
I love how you talk about experimenting with food and nutrition and seeing how you feel and, using the science, to determine what experiments you're gonna make with yourself, but then using how you feel as part of the data, because as we all know, we're all different. And that's a big part of what Vojo does. So at Vojo, we help people eat in the best way for their bodies, using your DNA, yes, as like a starting point to figure out some of those things of what you could do, which is better for you. But then also listening to your body, doing these things, seeing how you feel. It's such a big part of it. So I'm really glad that you said that.
I think people extrapolate their experiences to other people and say, you have to do what I did. And I understand that tendency. And I'm definitely susceptible to it. I would be a hypocrite if I said I wasn't. That said, we are just so remarkably bio-individual. So I like to say, in the hierarchy of, I have a little pyramid in my head, of like research studies, quality research studies. I think epidemiology, population-based studies kind of are at the bottom for using them to inform personal health changes. And we can talk about that because I think that's often an error that's made in society. We do have things like randomized control trials, which are pretty good, but I think the best study of all, better than a randomized control trial, is your N=1 experience. Because even in those randomized control trials, there's a standard deviation. There's a little bit of noise based on individual variability. And the only way to wash that all out is to try it in you. You're a unique individual with unique genetics, unique lifestyle factors, unique cultural factors, and, we can get into it, but the microbiome, man, that it's so complicated in space and time, and I literally mean in time, over the course of a day, how things change, and among individuals. So, we're not at the point, I'll tell you right now, we're not at the point where we can really, just deduce based on your metabolic metrics and your microbiome what might be best for you, really. You just kind of need to play with things. Plus, none of these things are static. They're always dynamic anyway. So even if we got a perfect picture at one point in time, it's going to be different 3 hours later, I'll tell you.
Yeah, having as much information about yourself as possible is great, but I agree, the microbiome is a whole other story.
Really interested in circadian rhythm around the microbiome, because I was noticing in myself and others how important food timing is to how we feel, and there is some fascinating new and older literature on meal timing and how the microbiome fluctuates, and even how microbes in the gut migrate around over the course of the day. There's a 10-fold fluctuation in the endothelial niche of the microbes. So it's there's the microbes that are attached to the gut lining and that are communicating maybe directly with your somatic cells, your body cells, and they kind of ebb and flow in that niche over the course of the day as much as 10-fold, which is crazy. And there's other data showing that if you jet lag someone and then transplant their microbiome to mice, this was Thias in 2014, that you can induce obesity in the mice. They gained, it was something like a third more body weight despite no more caloric intake. Same caloric intake, it was just timing a microbiome composition. And we know that in humans night shift work and frequent flying are associated with these metabolic dysfunctions. And this is just one little tip of an iceberg in a sea of icebergs, and the complexity of the microbiome and the metabolome, which is why I now think food as medicine is anything but fluffy. It's the hardest core science there is, and there's so much to explore.
So tell us, what is the difference between dementia and Alzheimer's disease? Your paper was about Alzheimer's disease specifically, right?
Yes. So they're often confused. Dementia refers to an abnormally sharp decline in cognitive function with aging. So not part of normal aging, but you develop serious cognitive impairment. Alzheimer's disease is the most common subset of dementia. So Alzheimer's disease is a type of dementia, but there are other types of dementia like Lewy body dementia, which is what Robin Williams suffered from and is often associated with Parkinson's disease. There's frontotemporal dementia, there's vascular dementia. And the thing is, a lot of these are not mutually exclusive. They're actually overlapping. We try to pin a particular disease, say, based on a certain pathology. So in Alzheimer's disease, the core pathologies, which people might have heard about, often simple words are harder for me than scientific words. I don't know why, but Alzheimer's disease is often associated with amyloid and tau pathology. So amyloid plaques and tau neurofibrillary tangles, whereas in Parkinson's-related dementias like Lewy bodies, it's often alpha-synuclein. But if you actually look in the brain of people with these diseases, there are often overlapping pathologies with the vascular issues in Alzheimer's disease or alpha-synuclein in Alzheimer's disease X, Y, and Z, which makes these really hard because we like to put labels on things, but it's not always quite so clear. And there might be many different subtypes and many different causes of Alzheimer's disease. But basically speaking, Alzheimer's disease is a subset of dementia. It's the most common cause of dementia, and it's typified by having amyloid and tau pathologies in the brain. Those are the two hallmarks of Alzheimer's disease, which you can see upon post-mortem after-death analyses. And so if you have serious cognitive decline, you're, failing or scoring low on cognitive tests, and then you have amyloid and tau in the brain, then you're diagnosed with Alzheimer's disease.
Okay, what are amyloid and tau proteins? Give us a quick lowdown on what these are.
So, this can get very complicated, but the basic amyloid cascade, one of the oldest hypotheses of Alzheimer's disease is that there is this protein amyloid, which is formed from amyloid precursor protein, which is a transmembrane protein. So you have in your brain cells, at the cell membrane, you have this protein that sticks through. It's called amyloid precursor protein. And if it's processed in a particular way, then you can get these little amyloid fractions, like amyloid beta 40 or 42, that are floating around, and they can start to clump up and form oligomers, little combinations that can be neurotoxic, and eventually they can form plaques. It's actually the oligomer stage that is thought to be somewhat neurotoxic and can lead to a cascade of events that precipitate tau pathology. So tau is a protein associated with microtubules, and when tau becomes phosphorylated, it comes off of microtubules, and that causes a destabilization of the skeleton of brain cells, basically. They start to break down, but also these neurofibrillary tangles, these phosphotau neurofibrillary tangles, they start to clump up inside brain cells and choke the brain from the inside out. Now, that kind of profile of Alzheimer's disease does miss a lot of nuance. People think about, okay, amyloid causes tau, causes Alzheimer's disease. Those are just markers of Alzheimer's disease. Just like a cough is a marker of you having some sort of infection. It doesn't actually tell you what the infection is or describe all the things that are going on underneath. So in Alzheimer's disease, we're now starting to think about it a lot as a metabolic syndrome of sorts in the brain, where you have insulin resistance in the brain, so that's similar to type 2 diabetes. You have lots of inflammation in the brain, and changes in glucose metabolism, mitochondrial dysfunction. All these things are now also known to be core causes of Alzheimer's disease, and that's probably why it's so difficult to treat, is because you really can't try to hit any one thing. There isn't a clear domino chain of events where you can just intervene. It's a really complex network. An analogy, and I forget who I should attribute this to, but an analogy I heard that I think is quite good is that a brain with Alzheimer's disease is like a brain with 100 holes. Sorry, a brain with Alzheimer's disease is like a ship with 100 holes in the hull that is sinking. And what we try to do with, say, drugs, when you're targeting a single protein or pathway, is trying to plug one hole at a time. Even if you plug the biggest hole, the ship's still going to be sinking. The only way to fix it is first to not generate holes in the first place, or plug up a bunch of holes at once, all the holes really. And that's really, really difficult. But all these things are interweaving, so again, when you improve metabolic health, and you're improving insulin resistance and inflammation, all these things track together. Which is why focusing on your metabolic health when you're young can really, I think, help to prevent all pathologies of Alzheimer's disease. It stops this vicious cycle of things like inflammation and insulin resistance, mitochondrial dysfunction, which all feed off of each other. It stops it from starting in the first place, which is exactly what you want to do.
Yeah, we hear about now that dementia is diabetes type 3, right?
Yeah.
And we've been through the same process with diabetes, like some years ago. It's a disease that happens to people. You take medication for it. That's all you can do.
Yeah.
Now we realize that it is something you can do, like a disease you can do something about with your diet and lifestyle. You can prevent it, and you can do something about it when you have it. And we're going through that journey with dementia and Alzheimer's now, like you said. And we have a lot of data that shows that dementia is associated with poor diet, poor lifestyle, smoking, not exercising, all of these things. But there are, as we said earlier, there's a gene, well, there are genetics, but particularly one gene, this ApoE4 allele, which dramatically increases your risk. So tell us more about that. What is this gene, and what effect does it have?
So genes come in different flavors. They're called alleles. And there's a gene called ApoE, which codes for a lipoprotein called also ApoE. Thankfully, this time scientists didn't name the gene and the protein differently, which they also do, so it's quite clear. And there are 3 varieties of this gene, 3 alleles coding for 3 variations of the protein. So there's ApoE3, which is kind of the most common among humans, ApoE2, which is protective against Alzheimer's disease, and ApoE4, which increases your risk of Alzheimer's disease. Now, everybody has 2 copies of ApoE. So you can have any combination of 2 copies of ApoE2, 3, and 4. So if you have 2, you're very protected against Alzheimer's disease. If you have 4, you're at much higher risk for having Alzheimer's disease. So these things kind of interact. Now, how does the ApoE4 allele, the ApoE4 protein variant, increase risk for Alzheimer's disease? That is the literally, what is it? I guess $3.32 trillion question based on how much it would cost to supply all the people that are suffering with Alzheimer's disease now for the new drug that was just approved if you're treating from 10 years. So it's, anyway, expensive question. We don't really understand. ApoE is, I think, one of the most interesting and complex lipoproteins that there are. There are multiple, or proteins that there are. It's not just, so in the periphery, what lipoproteins do is they're associated with lipid-carrying particles, like you might have heard of LDL cholesterol. That's ApoB, 100. Or HDL cholesterol. That's some ApoAs. ApoE is also in the periphery. There's ApoC, various forms of ApoC, ApoD, X, Y, and Z. Not X, Y, and Z, but like more of them. But in the brain, ApoE is a very important lipoprotein for carrying around cholesterol and trafficking fats, but it's also transcriptionally active. It changes the way genes are expressed. It modulates immune function and inflammation status in the brain. It changes brain metabolism, how well you metabolize, say, fats versus carbs, X, Y, Z. We're still really early on in our understanding about how ApoE affects brain metabolism. And obviously the brain's pretty hard to study in living humans, which makes, discovering the function of ApoE protein really difficult. But so I'd say it does a lot of things. More than can be simply expressed.
Yeah, I mean, nutrition research is already difficult, as we already discussed, and then studying a disease, a chronic disease, which starts later in life. Like how do you study that? There's a very long-term studies, and then in the brain as well. Like there are a lot of barriers going on here. But as you've gone,
I'm just going to say, I joke, but I'm sure a lot of people in the nutrition space have heard about like autophagy. You want to activate autophagy to help clean things out. And being someone who does conduct research and understands to some degree how what research studies can be conducted and can't, I always hear, this is like a pet peeve of mine, just a funny one, about like autophagy, fasting activating autophagy in the brain. And I believe it does. But it's become quite common, at least among the intermittent fasting community or the low-carb community, to say, you can activate autophagy in the brain within, 12 to 16 hours of fasting. I'm like, where did those cutoffs come from? Because guess what? To do that study, to make that confirmation, you need to take people to fast them for various periods of time, then chop their heads off and do staining for like LC 3-2 and stuff. I'm like, I don't think that study's been conducted. I'd be really interested how the researchers got like participants and ethical approval, but anyway, yeah, studying the brain in humans is super hard. So what we ended up having to do, for practical reasons, is extrapolate from mechanistic mouse models or in vitro studies, and then we can do some tracer studies and like PET and fMRI imaging. So those we can do, but they can only give you so much insight. That said, more technologies come out every day, so who knows?
Okay, so you mentioned that about 25 to 40% of people have this E4 allele, right? 20 to 25. Yeah. Okay. So that doesn't mean you're definitely going to get Alzheimer's disease, obviously.
Not at all.
What are some examples of different populations that have this allele that show how you can change your lifestyle and diet to modify the outcome?
The key example that ApoE is not causative of Alzheimer's disease. There are 3 genes that can actually cause early Alzheimer's disease, but they're quite rare. The key example with ApoE4 is the Nigerians. So if you look in elderly Nigerians, those with ApoE4 are at no higher risk for developing Alzheimer's disease than those with ApoE3. If you look at elderly Nigerians with ApoE3 or ApoE4, they get Alzheimer's disease at the same rate. Now, one could argue that, maybe the Nigerian population has some sort of genetic linkage where there's another protective gene in them in particular, but no. If you look at comparative studies between Western Africans who live, say, in Nigeria or Western Africa versus those of similar genetic descent who live in, say, Indianapolis, it turns out, though, those living in Indianapolis get Alzheimer's disease at twice the rate. It's twice the prevalence, which suggests that there's some sort of lifestyle factor intervening. And then another good case is people living a traditional Mediterranean lifestyle. So there's a study of looking at extreme longevity. So people that live in the top 1% of the population, which is 95 for men and 99 for women. And if you're living that long, you probably didn't get Alzheimer's disease, because I think median survival after diagnosis is something like 3 to 6 years. So if you're living to be 100, you're probably doing it without Alzheimer's disease. But they found that those with ApoE4, Southern Italians with ApoE4, were just as likely, or even trending towards more likely, to live to be into the top 1% if they were living in Southern Italy. But if they were living in the United States, they had a much higher chance of dying before extreme old age. So again, suggesting lifestyle factors do play a role. Unfortunately, that's basically all we can say. All we can say is lifestyle factors play a role. We don't know exactly what lifestyle factors they are, and I think it's a stretch too far to say eating, say, a Nigerian diet or eating a Mediterranean diet is actually the thing contributing to the protective effect. It might be a contributing factor, but there are so many factors, and I think we do science and ourselves a disservice from making an assumption about any given variable in that constellation from the epidemiological data. So let me give you an example. There are multimodal interventions that are used, they say, to prevent Alzheimer's, but it's not really preventing, because all the people in the trials, when they're recruited, are over 65 years of age, and most of them are already showing cognitive decline. So the disease is already set in. But in these trials, what they often do, and there's only one that substratifies by ApoE4, I think it's called the finger trial, is they have a multimodal intervention where it's like, we're going to do stress reduction, you're going to do exercise, and you're going to do some sort of social engagement, and you're going to do this learning app, and you're going to do this diet as well, right? And that's great. I think for clinical interventions, you want to throw the kitchen sink of lifestyle interventions at people. I completely believe that. That said, it doesn't tell you anything about any one intervention. So think about it this way. Think about it if there's like a point system, and you got +1 point for exercise, +1 point for stress reduction, +1 point for better sleep. Then what if your diet was actually a bad diet and you did -2 points? You'd still be in a net positive, and the overall effect would be positive. So it's not fair to then assume that diet is actually a good diet. And since we don't have any long-term trials looking at, just a dietary intervention for preventing Alzheimer's disease, we kind of have to, again, like I said, do a bottom-up approach and think mechanistically what makes sense for which people. Personalize it a little bit, and then look at metabolic end markers and say, okay, what can we track to maybe prevent Alzheimer's disease? It's not a surefire thing, but it's a hell of a lot better than the alternative of just shrugging and being like, I don't know what I can do, so I'm just going to eat cheeseburgers, not sleep, play video games, and sit on my butt.
Yeah, I think most people, if they know they are at increased genetic risk, they're going to want to do something, even if there aren't these long-term, like randomized controlled trials or whatever that are pretty much impossible. So what can we do based on the data we have on the mechanistic studies if you have this gene?
Well, that's something I'm just gonna to say up front. I describe it in a little bit more detail in the paper you alluded to, Precision Nutrition for ApoE4, and we do provide just concrete tables for all the interventions you can do, so we can step by those step by step. But I think some things that we don't talk about particularly in this paper because it's focused on nutrition are things like sleep and exercise and stress reduction. I think those three factors are huge. They're not nutrition, but they're huge. To move your body, especially higher intensity exercise, I would say at least twice per week, and building up your lean muscle mass, I think is quite important. So resistance training and weight training, I think, is quite good. And then sleep, there are some people that can get away with fewer than 7 hours of sleep. They're called non-somniacs, and they're not that well studied, but most people, I would say, at least 7 hours. And practice good sleep hygiene. Sleep when a human being is supposed to sleep at night rather than being nocturnal. And then, stress reduction. That is the one that I probably am worst at, to be perfectly honest, but it is important. And so anything you can do to reduce your stress, be it yoga or exercise or just socializing, is important. And also we know that social engagement is actually very important. So those are a bunch of factors aside from nutrition that are important. Now, in terms of nutrition, again, it's very personal. What I would say is, I'm going to be political here, I would focus on the endpoints of metabolic health. What are you trying to achieve with your nutrition, and how can you actually measure that it's working? Because we're all very individual, and I think the key things to look at are you metabolically healthy? By which I mean there are particular markers you can look at in the blood, and we can go over these for whether or not your metabolism is running well, which is going to protect your brain. And right now, the scary thing, and maybe one of the reasons Alzheimer's rates are going through the roof because our genes aren't changing, is our metabolic health is getting worse and worse and worse. We're getting more obese right now. I think it's 42.4% obesity in the United States. We're getting more diabetic. Right now it's 1 in 10. By mid-century it's supposed to be something like 1 in 3. And I think already 1 in 3 are diabetic or pre-diabetic. And 88% of people, as of I think it was a 2019 study based on 2016 NHANES data, so it's probably worse now, 88% of people are not metabolically healthy. They have at least one marker of the metabolic syndrome. So these are the markers that I was referring to. You have the metabolic syndrome if you have any one of the following three variables. If you have a high waist circumference, denoting a lot of visceral adiposity. So there are different types of fat, and it's the fat that's hidden inside your abdominal cavity that's the worst. So the pear-shaped person, less than the apple-shaped person. And there are such things as metabolically healthy obese person. That's a tangent we can get into. But visceral adiposity, high fasting glucose or insulin. I actually like insulin better as a marker because I think, what we can talk about, but insulin levels will rise far before glucose levels shoot up and you're diagnosed with prediabetes or diabetes. So high waist circumference, high fasting glucose or insulin, having high blood pressure or hypertension, and then having low HDL cholesterol, the quote, good cholesterol, that's a complicated topic, and high triglycerides in the blood. So high levels of fat in the blood, which does not mean it's coming from dietary fat. That's something that's frequently misunderstood. But having low HDL cholesterol and high triglycerides in the blood are also key lipid markers of poor metabolic health. Whereas something like LDL cholesterol is actually not a marker at all of metabolic health.
So with all of these markers, if you're looking at these blood markers, could it still be the case that your brain metabolism still might not be doing well, but you wouldn't be able to see it in these markers that you just described?
It definitely is possible. That said, if you achieve optimal levels for all of these things, chances are your brain is functioning pretty well for you. I'll say it like that. But another thing I'll add is that the reference ranges and the cutoffs clinically for some of these things are not what I would consider optimal. So, for example, insulin. And I want to clarify, I'm not a medical doctor yet, so take what I say with a grain of salt. But I have consulted a lot of medical doctors and a lot of scientists, and I am a scientist, so take that as you will. The reference range for insulin is anything below 25 to 30 microunits per liter, depending on what lab you go to, is normal. I would say you want your fasting insulin below, most liberally 8, maybe below 5 microunits per liter. So it's very different than the clinical reference range. And it's the same for, say, triglycerides. Triglycerides are, quote, normal if they're below 150 milligrams per deciliter. I like to see levels below 100, even below 80, if I'm focusing on optimal metabolic health. And then similar with things like visceral adiposity. So the reference ranges for, quote, what is normal doesn't necessarily show you what is optimal. But if you achieve relatively optimal, in all of these categories, I think that's step one. It doesn't mean you're never going to get Alzheimer's disease, but this is the way I put it for people who are at least ApoE4. All right, if 88% of people now are metabolically unhealthy, being ApoE3 only, or ApoE2, you can get away with being in the 88%, maybe. You could still get Alzheimer's disease, but you can get away with being in the 88%. If you have ApoE4, you have very little wiggle room. I would say you might not be able to get away as easily being in that 88%. If you have 2 copies of ApoE4, I'd say you really want to be in that 12%, at least. Again, that doesn't mean you're not going to get Alzheimer's disease, but I think now you stand a shot. And then you can focus on optimizing other things that getting enough good fatty DHA for your brain, which comes from like fatty fish, which can build up, say, over time, and other interventions to kind of further optimize. But I would say, as a starting point, it's like adding a vitamin C tablet onto eating cheeseburgers. If you're trying to do like supplements, but you're just eating a pretty bad diet and your metabolic health's not in order. So I think the base of the pyramid for Alzheimer's prevention is getting those 5 markers as close to optimal as possible, with nutrition and exercise and sleep and stuff like that.
I speak to some people who say they don't want to know their genotype, whether they have ApoE4. And I find that a bit strange because, like you said, even though there are lots of things we don't know, there are lots of unknowns, but there are some things we do know. And like you said, if you do have 1 copy of this allele, then you do need to be more careful. And if you have both, then you really have to start thinking about your health a bit more. Do you think people are better off knowing? Or, another thing you talked about with stress reduction, do you think the added stress of knowing this is actually counterproductive?
Very good question. And not one that I think any individual can answer for any other individual. Just because you have to know yourself and how you're going to react to that kind of news if you're going to seek out that information. I think some people would argue that, look, it will scare me and I won't change my lifestyle, so why no? Other people would argue, okay, I'm going to change my lifestyle no matter what, and having this information won't provide me further motivation. Whereas some people are in between and like, no, if there is this, I want to know because not only do I want to have lifestyle interventions, but I want to do lifestyle interventions to precisely target my genotype, which is not an easy thing to do. I mean, thinking about how overwhelming trying to figure out, okay, what would fit my genotype based on the data we have, like that's a hard thing for a lay person to do. In fact, this paper that I recently wrote, it was a paper that I always wanted to write. I never had just time in my life. And I was at this point, a scientist doing brain research. This wasn't my area of research, to like go and research and write this paper. So there was like a little break where I'm like, now I want to sit and actually try to figure this out and write this paper, which is something I always wanted to do. But most people aren't, So maybe my paper can be helpful to people now to guide them if, they buy the mechanistic argument. But I think in general, with precision nutrition, there's just so much we don't know, and it's so complicated to try to figure out what you actually should do. I think something you and I agree with on, I suspect, Ellie, is like how saturated and confusing nutrition media is now. You hear so many controversial things. Eggs are bad, eggs are good, meat is healthy, meat is unhealthy, X, Y, Z. And you just don't know who to believe. It becomes a huge he said, she said. And you kind of have to be a proper scientist to be able to figure out who's feeding you what you perceive to be reality. Otherwise, it's just two people who are posing as experts. And if they both know more than you, then how can you possibly know who to follow? And it's just completely confusing. So I think, rightly so, people want to turn away from that and stick their head in the sand to some degree. So it's unfortunate, but that's where we are.
Well, turn away from it and also turn towards what they can find out about themselves. Like, you're totally right. There's a whole media problem of scientific communication and all of that stuff. But then also, even before that, you've got methodological problems in studies. You have, even with Alzheimer's research, like there's a lot of problems already, but there's so many studies that don't take into account the genotype. They don't look in genes.
Stratification.
So that's...
and it's complicated because all these genes are modified by other genes. Most traits are polygenic. A lot of genes contribute. So there are particular studies that can look at maybe, does a gene contribute, Mendelian randomization studies or GWAS studies, genome-wide association studies. But I think, you need to power your research towards doing that. Whereas if you're doing another sort of research, then you're just like... You're not going to put your resources towards doing a full genetic screen on each individual participant. You have to power your I wish that research had unlimited money, but no trial is ever going to be ideal. So I wouldn't criticize researchers for not doing genetic testing. I think it's beyond where we are, and sometimes it's more misleading than helpful.
Talking about controversy, you mention ketogenic diets quite a lot in this paper of yours. So
yeah, I mean,
tell us a bit about that.
I kind of was trying to know my audience here and beat around the bush earlier when I was talking about the intervention that really transformed my life. So I'll reveal my bias. It was a ketogenic diet, and the fact that a ketogenic diet had such a strong impact on me, and I think to save my life, is going to bias me towards looking for research to support that life narrative. I think it's fair to claim that bias. I think we all have our biases, and when we ignore them, we can't compensate for them. So I try to compensate for them, and I try to consider myself a agnostic, but everybody listening should know that is my backstory, and that is the baggage I carry. That said, I do think ketogenic diets are very misunderstood and misrepresented in the literature. And I want to talk a little bit about that first, and then we can talk about the relevance to Alzheimer's disease. But a ketogenic diet, basically speaking, is a diet that puts you in the metabolic state of ketosis, which is where your liver is turning fat, either from your diet or from your body fat, into these molecules called ketone bodies, which are great fuel for the brain, other tissues, and they're also potent signaling molecules. They bind to receptors on cell surfaces, they go inside cells and change gene expression, they're post-translational modifiers, they are hormones, especially beta-hydroxybutyrate. So the thing about a ketogenic diet, though, is it's a metabolic state. It's not a diet like other diets. So it's perpendicular to all other diets. You want to be a vegan keto, you can do it. Vegetarian keto, you can do it. Carnivore keto, you can do it. Mediterranean keto, you can do it. Pescatarian keto, you can do it. Whatever keto, you can do it. It's a metabolic state that's complementary and can intersect with almost every other diet you can imagine, which is why I wrote the book I wrote about Mediterranean ketogenic diets, to put that face on what a ketogenic diet can be. It can be salmon and avocado and olive oil and all that stuff, and leafy greens and eat the rainbow, whatever you want, if that's what you want to make it, although that's not what you have to make it. Now, as most people listening probably know, a ketogenic diet is a low-carb, high-fat diet. And I think that's where people get hung up, on the carbohydrate restriction, because most standard guidelines would tell us to eat carbs as fuel, and on the aspect of eating lots of fat, which we think of as unhealthy. And in fact, we get pushed that message so much, like fat is bad, even though there's a little bit of nuance to it. I think people have a very visceral reaction, an emotional reaction to eating fat, eating high fat, or the concept of eating high fat, even beyond the intellectual and conscious aspect. And I can tell you personally that before I tried a ketogenic diet, which again I said I tried because I felt desperate, I actually understood, well, evolutionarily, mechanistically, this actually makes a lot of sense for human physiology to restrict carbohydrates and eat more fat to be healthier. That said, you just internalize the message of low fat after seeing so many Special K and Yoplait ads your entire life. And it's kind of hard to overcome until you actually give it a shot for yourself and experience the potential benefits. So, there are a lot of myths to bust. First of all, does your body need carbohydrates? No. There are essential fatty acids, there are essential proteins or amino acids. There's no such thing as an essential carbohydrate. You can go without any dietary carbohydrates. I'm not saying you have to, or that you should necessarily. I'm saying you can, because your body can make all the carbs it needs. And then eating high fat doesn't do the things that it does in a mixed diet if you're carb restricted. Then the rules change because you're a fat burner. So you might think, okay, what happens if you eat more fat and fewer carbs, including more saturated fat? So if I ask you, Ellie, I'm going to trade the carbs in your diet for fat, what do you think will happen to the triglycerides, remember this marker of metabolic health that I said earlier, in your blood? Do you think they'll go up or down if you eat more fat and fewer carbs? They'll go up. You'd think they go up.
Let's say, we're eating fat. They'll go up.
And I know you probably knew the answer to that one based on how I was leading you, but that's been shown even in randomized controlled crossover trials. So there was one, for example, published in 2019 by Hyde et al. People can look it up, HYDE, where they took people with metabolic syndrome and they put them on isocaloric, same calorie diets, and they only swapped the carbs for fat, including they were eating a healthy whole foods diet with your 5 a day for the carbs, and they were trading them for fat. The high fat group was eating, I think, 45 grams of carbs versus a lot more in the high carb group, but they were eating 100 grams of saturated fat a day, so 2.5 times more saturated fat, and I think 3 times more total fat-ish than the low fat group, and yet the fat in their blood went down significantly. It was lower, and the saturated fat in their blood was lower. The reason is, the fat in your blood derives mostly from carbohydrates. So if you have carbohydrates and you spike your insulin, that sends a signal to your liver to turn those carbs into fat, specifically saturated fat, palmitic acid, and palmitoleic acid that get dumped into the bloodstream. And that's mostly what you see, whereas if you're in fat burning mode, yes, fat has to get trafficked around your body, but then you burn it up, and your fat cells, they gobble up. Not your fat cells, your muscle cells, more so than your fat cells, they'll gobble up and burn that fat, so the fat levels in your blood go down. There's some really interesting counterintuitive things with metabolism. I'll give you actually another example, because this one blew my mind when I'm going to explain it, and it's going to be the kind of thing I'm going to warn people, they're going to want to go back and listen to, because it's just going to be like, wait, what? So I'm warning you. Okay, let's imagine that you're low carb, all things being equal. So you're already low carb, right? And eating a high fat diet. What if you just pound fat, saturated fat? You're drinking 1.6 liters of heavy cream a day, eating 6,000 calories and just fat, lots of saturated fat. You would think the fat in your blood and your LDL cholesterol, which we think, saturated fat boosts LDL cholesterol levels. That's actually known. You'd think it'd go up. Turns out it goes down, a fasting lipid panel, which is so weird. Why would it go down? I can share with you a blog where a friend, and do not do this at home, this is not healthy. I'm not saying it's healthy by any means, but it can show that acutely, pounding fat and saturated fat, if you're low carb, can make triglycerides and LDL cholesterol and things like Lp(a) and LDLP all drop in your blood, having to do with just the mechanisms of how these things are trafficked in the body. In this case, what ends up happening is the fat gets trafficked very fast to your fat cells where it gets stored, because when you're eating a lot, if you're eating, say, 6,000 calories a day, even if it's low carb, you're going to be spiking your insulin, which is a hormone that causes fat cells to swell up and grow. And so now you're supplying a lot of fat. Your fat cells are growing. They're sucking up more fat from the blood to grow, and they're sucking up cholesterol particles to help them grow structurally. So what ends up happening is, because the fat can be deposited from your diet quite fast, and you have higher basal insulin levels stimulating more fat growth. In the fasted state, you just suck up more fat into the fat cells, and you suck up more cholesterol particles. So what you end up having is really low LDL cholesterol and really low fat in the blood. Again, not a healthy thing to do, but really counterintuitive. And another example I want to bring up, just to make the point that it's really easy to mislead people with nutrition science by saying, oh, eating butter is going to increase your fat in the blood and therefore going to cause heart disease. When if you actually look at the clinical trial data and like the HYDE trial, and you start to think about the mechanisms in the biology, it turns out that's not what happens. And it seems completely counterintuitive, but people say you are what you eat, and I say, when was biology ever so simple? And so those are the kind of complicating things that lead to a misunderstanding of ketogenic diets, which tend to lead to great improvements in these markers of metabolic health, or even low-carb diets. So, for example, this HYDE trial was not a ketogenic diet. It was 20% calories from carbs, which is not ketogenic. And so it's depending on what your goals are. I do think ketosis has advantages for certain conditions like inflammatory bowel disease or neurological disorders when they're active. But if you're interested in improving those 5 markers of metabolic health that I mentioned, any form of therapeutic carbohydrate reduction, which does not have to be keto, it does stand a chance of significantly improving your metabolic health. So the last thing I'll say on this, because I've been rambling a little bit, and then I'll give the floor back to you, is people should not say that carbohydrates cause disease. Carbohydrates as a macronutrient are not evil. I am very pro-keto. I am pro-low carb. I do not believe carbohydrates cause metabolic disease. That said, sugar and refined carbohydrates probably do. And saying carbohydrates don't cause metabolic disease is very different than saying carbohydrate reduction isn't a great tool for reversing metabolic disease and metabolic syndrome once it's there. And the data seem to suggest that on the whole, again, I'm not telling you about any individual, but on the whole, carbohydrate reduction is the best thing for reversing metabolic syndrome. You can read the HYDE trial if you don't believe me. And achieving being in that 12%. Which is why I think low carbohydrate diets are relevant for a lot of people, is because we have 88% of people who are metabolically unhealthy. If 88% were metabolically healthy, I think it would be an intervention that maybe fewer people should consider. But we are where we are.
Yeah, I have to say, if I didn't know my ApoE4 status, I'd probably eat more sugar than I do now. I don't need any sugar now, but I'd probably be more flexible.
Yeah. I think Nigerians eat 1/4 the sugar of Americans, FYI. We were talking about Nigerians earlier, so, just part of the puzzle. Again, I don't want to extrapolate. It's correlational evidence, but...
It's quite a big difference, but yeah.
Yeah. What do we eat now? Like 90 pounds per year per person or something? Something absurd. And it's more in children. It's some absurd amount of like...
I don't know what a pound is. I'm sorry.
454 grams. So
okay, cool.
So a crazy amount of sugar, added sugar. So I'm not even talking about like sugar in bananas or something. I'm talking about just like added sugar to things. It's quite absurd.
It's insane.
Everywhere. But it's hidden. It's like people don't know where sugar is. You don't assume that they put like... You go to the grocery store and like sugar's in like 90% of things. Like even in your...
And it has different names. You just don't when you look at the ingredients, it's like there's a million different names for sugar.
Oh yeah, it's hidden under so many different like oses and alls and syrups, and they try to make it sound healthy, like organic cane sugar. Guess what? The molecule is still the same molecule. It's just sugar. Brown rice syrup, sugar. In fact, here's something I found like appalling ethically. Boost Soothe Nutrition, I think it is. It's like a nutritional supplement. And you look at the nutrition label, and I think this is, I've seen diabetics drinking this because they think it's supposed to be complete nutrition. And it's only, quote, 15 grams of sugar, which first of all is a lot. 15 grams from, I think it was cane sugar. But then you look at the nutrition label, and it's a single drink. It's 65 grams of carbs, 0 grams of fiber, and 15 grams of sugar. So my question is, where are the other 50 grams of carbs coming from? Where are the 50 grams of net carbs coming from? And I think the first ingredient after water is brown rice syrup, which, for whatever reason, doesn't need to be classified on the label as sugar, despite the fact that it's mostly maltose, 65 to 85% maltose, which has the highest glycemic index of any sugar, even higher than glucose. And yet, it just goes into the ether as those 50 grams of non-sugar carbohydrates. And people are just drinking high glycemic index sugar.
Yeah, it's mad.
Everywhere, and people aren't aware, not to any fault of their own. And the serving sizes are a joke. Serving sizes for cereal make me laugh. I used to eat Special K berry cereal when I was young because I thought it was like healthy. You got the ads like, oh, it's strawberries, and it's like a diet cereal. And not that I was super into dieting, but I'm like, oh, it's healthy. I ate a box a day, which was 11 servings. And it was just
how much sugar was in that?
I don't even know. I did a tally of how much sugar I ate when I was around 11 to 13, like retrospectively, and I ate over a kilogram of sugar, over 1,000 grams of sugar a day. I would sit in bed at 9 p.m. at night after having dinner and eat a thing of, I thought I was being healthy, and my parents encouraged this, orange-flavored craisins, the dried cranberries. There were 4 servings in that for a total of 138 grams of sugar, right as I was going to bed, as like an 11-year-old. How I was not morbidly obese, I have no freaking clue, but I used to have tons of sugar thinking it was healthy, including sugar from like baked beans. They say beans are healthy, so I would down cans of Boston baked beans, which are just like in bean like sugar syrup, just like whatever sauce. And yeah, sugar is everywhere, from deli meat to whatever, like anything. They put it in, like, if you get like pickled herring, you're like, oh, I'm gonna eat fish. Pickled herring. Go look at the jar. I bet you it has sugar on it. I bet you if you went to your deli meat, I bet you there's not a lot of it, but I bet you it'll say dextrose. There is so much sugar, and at restaurants as well. The dressings, salad dressings, it's everywhere. Yeah,
my favourites are the ones that sound healthy. So coconut blossom sugar, that's in a lot of healthy chocolate nowadays. Yeah. And yeah, it's just sugar. Yeah. There's no difference.
Oh yeah, it's artificial sweeteners and non-nutritive sweeteners is a very interesting topic. And I would say, I do want to tangent that because I assume it's something that's coming to people's mind if they don't want to give up sugar, which I think is an experiment everybody should do. Because guess what? Once you give it up and the addiction is released, and yes, sugar can be addictive, that's a whole other topic. Like, you cannot believe the life freedom and also how much more you enjoy. Like, now when I have like a couple blueberries or like 1 or 2 dried cherries, I swear they are more pleasurable and sweeter to me than ice cream ever was. And I used to be able to just like down 12-person ice creams at Friendly's. My dad goaded me into doing that once when I was 13, so I actually did that. But anyway, you can adapt, have hope. But with respect to non-nutritive sweeteners, what I'll say briefly is stay away from saccharin, aspartame, sucralose, like Diet Coke. The ones that will get my potential seal of approval, and I prefer to do none of them myself, but if you're going to do them, I would say stevia, monk fruit, erythritol, and allulose are all probably the best ones with least likely impact on the microbiome and least likely impact on your metabolism and your insulin levels. Whereas things like saccharin have been shown to cause glucose intolerance by causing microbiome dysbiosis. I think that was Segal, an Israeli group in 2015 in Nature or something. It's been shown, I think relatively conclusively, that not all people, but some people, in fact I think the majority in this study was 4 out of 7, will respond with metabolic disruptions if they're having saccharin, or probably also things aspartame and Diet Coke and stuff. So it's up to you whether or not you want to gamble on it. you couldn't make me drink a Diet Coke. I would eat 4 sticks of butter beforehand.
Would you rather drink a normal Coke or a Diet Coke?
That's a hard one.
I know ideally neither, but
I don't know.
play the game.
I know. I hate when people, like, you give people, like, a hypothetical and, like, neither. I don't want to play. I feel like it just ruins it. All right, I'm going to go with, for me, Diet Coke. Reason being, if I come out of ketosis for too long, I personally get a lot of inflammatory issues. Whereas I think if I'm generally otherwise metabolically healthy, I'd probably just say Coke. And I'll just take a little bit of a glucose hit, but my body can take that one shot. But in my current state, I'm going to say Diet Coke.
How long does it take you to get back into ketosis if you have sugar or a cup or more carbs?
I mean, it depends on how much and how metabolically flexible you are. Really, ketosis is determined by how much it has to do with, like, the glycogen stores in your liver, so to speak. And so how fast you can deplete them will determine how fast you can get back into ketosis. So, if I had, and I don't do this necessarily because it doesn't make me feel so good, but if I had 100 grams of carbs, I could be back into ketosis probably the next day, just because of how those carbs will be petitioned to my body, because I could fast, because I could do some sort of exercise. I could do it. Most people, I would say, it would take, if you've never been in ketosis, 2 to 3-ish days of not eating really carbohydrates, eating below 20 grams of carbohydrates and keeping your protein moderate, definitely below 1 gram per pound, to start to get into ketosis, which doesn't mean your body is adapted to using ketones. And I think a key thing with ketogenic diets, if you're going to try it, which you don't have to, but if you're going to try it, you need to give it at least 6 weeks, minimum, because your body needs to adapt. The thing with most of us is because of our social structure and food environment, the way we eat, our bodies can't really burn fat that well. We've down-regulated those enzymes and those pathways. And you need to reteach your body to do that, kind of like learning a foreign language. And so it's like immersion at the beginning. It's not about going into and out of low carb. If you're going to try it, if you wanted to try a ketogenic diet, then I would say, first of all, find a community, find support, find a coach, because anybody can do it. I've literally coached, like, full-time chefs who are, insulin resistant and obese on doing it, and they do great. Like, anybody can do it if you have support and help you, troubleshoot it. So it can be done. You can do it. But also give it a serious period of time, because it's one of those things where sometimes the grass is greener on the other side for some people, that they have to go through a little bit of adaptation. But to actually get into ketosis and see the levels in your blood, a few days. And if you're fasting would peak at like 4 to 5 days of fasting. I'm not saying do that, but that's when you get to levels of like 4, 5, 6 millimoles. It's actually very interesting. I'll just say, because we were before we tangented talking about the brain, the zen feeling you feel when you're in nutritional ketosis. The most frequent thing you'll hear is, I went on a ketogenic diet for reason X, often weight loss, but I'm remaining on it because how ridiculously good my brain feels. In fact, the reason we're the best animals at going into ketosis is because our big brains kind of made that a necessity, because ketones are such an amazing fuel for the brain, and we wouldn't have really been able to survive long periods of carbohydrate deprivation if we weren't really good at making ketones. And when you get into that state, you're just like zen. It made me, once I discovered a ketogenic diet, like ridiculously productive. Like I said, I did my PhD in 2 years while writing. I wrote, like, I'm patting myself on the back now, but just to be, as a case in point, like, 13 first author papers, a cookbook, like, while doing all these other things on the side. It's just, your mind is like on fire. And you definitely don't get those like 3 o'clock I'm tired lulls. And also, it's kind of funny. If you biotrack these metrics, like ketone bodies and glucose, you get this very eerie sixth sense for where your numbers are. So I now know when I wake up, depending on how exactly my gut is feeling and also my mind, I can tell you, I think my ketones are around 1.5 millimole. And I'll be right within 0.2 millimole were I to check. and I've done this again and again, like I have that intrinsic feeling, and I know people with prediabetes who use continuous glucose monitors who also get that feeling, like they can ballpark right where these blood markers are, showing you that they're relevant. And one of the reasons I actually promote, if people want to try it, monitoring blood ketones or using a continuous glucose monitor, even if you're not diabetic, which has been a whole weird hot topic on Twitter recently. I don't know if you've been following that, but it was like outrageous discussions about whether or not people without diabetes should have CGMs. So everybody knows my vote is yes.
For sure, yes. I mean, what was the argument against that?
I mean,
people have people can choose whether they want to measure their blood glucose or not.
My thing too, again, I'm not saying everybody has to have it. I'm saying it should be available to people who want to use this tool to get insight on their health. The arguments were having to do with the incentive structures of the companies, and also people misusing the data. I heard one physician say that, like, if it's going to teach my patient that they should not eat an apple and instead eat a lot of bacon because it's going to create a more stable blood glycemic response, then it's damaging information. And okay, fine, like that's a hyperbolic example, and any technology can be misused, but I don't think that's any good reason to keep people away from this technology. I can't speak to this as an authority, as a medical doctor, because medical doctors were chiming in, but I can speak to you as an authority, as a patient who has suffered without diabetes, with other medical conditions, in which I've actually made use of CGM myself with my IBS. My colitis hasn't been an issue, but I still have some IBS issues, and I can tell you it is a very useful technology for everybody to see how you respond to different foods. And there are trials showing, like, and this is a trial I can share with you so you can put it in the links, because there's a TED Talk associated with it, and it's fascinating. It was also by the Segal group, but where they showed we each have very individual responses to the same foods, irrespective of carbohydrate load and glycemic index. Which, let me reinforce that. We tend to think, something with a higher glycemic index is going to bump your blood sugar more, but it turns out that our unique microbiomes cause us to respond to specific foods differently. So, for example, in this trial, like, there were two participants who, if one ate a banana and a cookie, the cookie spiked their blood sugar more, maybe as to be expected, but the other person, it was reversed. Same food, but the banana actually spiked their blood sugar more, which is fascinating. And in fact, they were able to use machine learning in this paper, a machine learning algorithm, so that they could take a new cohort of people, apply the machine learning algorithm to microbiome samples, generate personalized kind of diet plans, which if you look in the talk, they'll show you, like, this is the good diet, this is the bad diet, and no nutritionist or dietitian or scientist or doctor can accurately guess which is the good or bad. And then you look at the continuous glucose monitor curves, and they are, like, so remarkably different. The good diet is so much better. In fact, the author of the paper, the senior author, Aaron Segal, jokes that I think his wife is a dietitian or a nutritionist, and like now she has some patients, or maybe this was in his book, but she has some patients who she says, okay, you're probably better off eating ice cream than white rice, and they have more ice cream and less white rice, and they end up dropping a lot of weight. It's just, it's very weird, and I'm very pro CGM. I have no problem saying that very publicly.
We're all so different, and this is just the main reason why we should figure out what's best for us. Like, it doesn't matter, it's completely irrelevant what works for someone else. Figure out what works for you. I actually tried to get a continuous blood glucose monitor from my doctor for free in the UK. Didn't work.
Yeah,
wouldn't give it to
you
me.
have to find a doctor who's willing to work with you. But yeah, well.
Yeah. I mean, they wouldn't even give one to my diabetic mum, so, they definitely weren't going to give one to me. I mean,
I have a friend with LADA, type 1.5 diabetes or whatever, a family friend, and like I have Dexcoms in my room, and I'm like, can I set you up with this? And he's like, no, I don't really want it. Which is fine. Like, nobody needs to do anything, but yeah, everybody's different. I think the key is nobody needs to have them, but if you want them, like this sort of technology gives. People are asking to take responsibility over their health. How can you not give them the tools to encourage that? And then, if there is misuse of that technology, it's a learning opportunity. you can explain, it not necessarily a bad thing, and it's a normal physiological response that a red pepper is going to spike your blood sugar more than, 30 strips of bacon. That's, it doesn't mean that 30 strips of bacon are better than the red pepper. And so let's have that discussion about what these glucose responses mean and what's normal and what's not. It's all about learning about your body. And this is such a great tool to be a catalyst for that, in my opinion.
I've heard a rumor that the new Apple Watch may include a non-invasive continuous glucose monitor.
I've also heard that Verily, Google's health medical arm center, what is it? Health center? I don't know. Sector is working on a contact lens that's a CGM. So I think we'll be seeing more of these. We're going to be seeing continuous ketone monitors probably coming out. I think it was Elon Musk that guessed that within 10 years-ish that we'd have like toilets that when we poop, we just get an immediate microbiome analysis that's sent straight to our doctor. What we're going to see in personalized bio tracking and continuous monitoring over the next 10 years is going to revolutionize how we think about healthcare. That's what I predict. And I can't wait until I have like an implant that just tells me all my metabolic markers all the time. Because right now we're taking things at like single time points and everything oscillates so much, be it whatever hormone or metabolite you want to think about. It's like oscillating on a ultradian rhythm, so multiple time points over the day, circadian over the day, like monthly and seasonal and yearly and over time, and all these things compound, and it's just, you need the continuous data. And we'll learn just then so much about how the whole body's metabolism is working. Right now, we basically know nothing. We're seeing like the first 2 inches of the ocean, which is kind of cool to think about. This is why I love this metabolism stuff, and why I think it's such a cool area to be delving into now, is because now this technology is coming out. Now they call them longitudinal multi-omics studies are coming out, where they take like your microbiome and your transcriptome and your proteome and your lipidome and everything at multiple time points, and like see after, say, exercise, how are all these things working together, and what is the choreography of your metabolism with different interventions, and what does that tell us about how the human body works? Like, what does it say when, oh, look, you're insulin resistant, and that actually flips the activity of these genes in response to exercise, which was shown in one trial called the molecular choreography of acute exercise in 2020. It's just so cool, I think, when you start to dig into it. We'll be learning a lot in the next 10, 20 years.
I want to double back to briefly talk about plant-based ketogenic diets. So there's been, there's a lot of people who say you can't be plant-based or vegan and ketogenic. Like, that's just too restrictive. What do you think about that?
I think doing a ketogenic diet, you can do low-carb vegan. Low-carb, ketogenic vegan can be done. It's quite hard because of the protein source. It's hard to get enough protein. So you're probably going to be on a pretty low protein diet if you're doing keto vegan. But I literally help people do keto vegan successfully. Not necessarily something I advise, but if they want to do it, they can. Plant-based vegan, mostly plants. So vegetarian, vegan. Not vegetarian, vegan. Vegetarian keto is very doable. You're just, especially if you're ovo-lacto vegetarian. But I mean, like, protein sources, things like tofu and tempeh can be included. If you're willing to be a little bit flexible, we can get into this with respect to the brain. Mm-hmm. I really do feel fatty fish is something that most people should eat. If you're not going to eat fatty fish, if you're a strict vegetarian or a vegan, I would suggest maybe getting an algae oil supplement. So the reason I push this is there are these long-chain omega-3 fatty acids, EPA and DHA, and DHA in particular is really, really important for brain health. In fact, sorry, my computer's low. I'm going to have to run and get a charger after I say this, so I'm going to take 2 seconds. But DHA is really important for brain health, and you can't really get it from plant sources. You can only get ALA, which is short chain, and some people will tell you that it can be converted into EPA and DHA, which is true. But this happens only at very, very, very low levels. It might be slightly higher in vegans. There might be an upregulation of the enzyme that converts ALA into EPA and DHA. But even so, you're not going to get conversion levels above at tops 9%. So it's really hard to get enough EPA and DHA on a vegetarian or vegan diet, but you can get EPA and DHA from algae oil, which is vegan. So if you're vegan, I do suggest an algae oil supplement. If you're not, or you're willing to eat fatty fish, I am a fan of having fatty fish at least twice per week, more for ApoE4s. Personally, I eat fatty fish every single day, and I will also tell people, say that my mercury levels are normal. That is something that is a concern for most people, rightly so. And so when you do eat fatty fish, if you do, low trophic level fish, small and freshwater fish are quite good. Avoid the tuna, especially the big eye tuna and the swordfish. You can even look up like mercury levels online. There's tables of fish, but like things like my 3 favorites, wild Alaskan sockeye salmon, North Atlantic mackerel, and sardines are great for a lot of EPA and DHA and being very low in mercury. I have those every single day and my mercury is normal. You don't have to, and there's trips to actually chelate mercury, but I am a fan of fatty fish.
So I'm actually trialing a ketogenic diet since the last week. And to be honest, felt like complete rubbish. The last week has been awful. I'm going to tell you, I didn't think keto flu was a thing. It's definitely a thing.
How many grams of sodium are you taking?
And
potassium.
My sodium intake is quite high.
Potassium and magnesium.
Liver, I have to say. Yeah, potassium. So I supplement magnesium, potassium. I'm eating enough potassium-rich foods.
You might have higher needs than you think. Most people don't get enough potassium. You need best is like 4.7 grams, which is like, 10 bananas, or 4.5 avocados. I find I do really well on pretty high potassium and pretty high magnesium. Like I'm probably getting 1.2 grams of magnesium a day and 4.5 to 5 grams of potassium. Also, one thing with plant-based keto, I will point out, some people need to supplement with carnitine. Reason being is your body can make carnitine. And the thing that carnitine does is it's part of the carnitine shuttle system that transports long-chain fatty acids into your mitochondria to be burned. But you mostly get carnitine from animal proteins. And if you're on a low-carb diet and you're increasing your fat metabolism, then you're going to need to be burning more fat. And if you don't have enough carnitine, you can have a carnitine deficiency if you're low-carb and plant-based. Then that can sometimes be a bottleneck for people. So sometimes a carnitine supplement will help, as just a thought.
I took carnitine yesterday and today, alongside some extra supplements as well, so choline and a few others. And I do feel better. I don't know if it's just a coincidence, like the hump of the metabolic changes over anyway, but agreed. There are people who do need to supplement these if you are plant-based.
Again, for these things, I would give it an honest shot of 6 days. 6 weeks. Some people would say longer, but and if you want to try it. And honestly, again, it's about endpoints. In fact, I remember I put out a video story about what happened to me including a ketogenic diet, and I got a lot of super nice responses, but one of the first responses I got was this woman from New Zealand who was talking about her cancer and the fact that she went like completely vegan and she thought it was helping her. And it was just the most wonderful thing to hear from someone who had a wonderful health journey. And the thing I immediately said is like, I'm so happy for you, good for you, whatever's working for you. So I really do mean this when I say it's about the endpoints. And I can't see inside you and what those metabolic markers are. You have to be honest with yourself about, what if what you're doing you think is optimal for you. And if you think it is, then, and you track things and you improve, then great. I think it's sometimes very hard without powerful motivation to make a huge shift. And honestly, I know I wouldn't have tried a ketogenic diet if I weren't super desperate. So I'd never pass judgment on others for not wanting to take it on. I am at the same time a degree of evangelical about how much it can help people, not necessarily like you. You look like pretty lean and healthy, but when I see someone really struggling with like trying to lose weight,
or like reverse diabetes, or struggling with diabetes. It's just like, for those things in particular, I do think it is probably the most powerful lever you can have. To see someone that has been struggling with obesity their entire life be like, I have no cravings and I'm dropping weight like nothing and I don't have to exercise and I feel great. Why didn't I discover this 40 years ago? It changed my life, and they're crying tears of joy. Or somebody with a mental illness, because it's really big in that space now, recover, then, it's just the most wonderful thing. But, you look young and healthy, so you do you. And anybody do themselves.
That's actually one of the the first things I've noticed, and the main symptom that I've had, or the main effect, is a complete reduction in appetite. And my weight is fine, I'm perfectly happy with it, but having said that, I have struggled all my life with appetite. Like, I have a big appetite, and I have all the genes associated with eating more calories and not being sensitive to leptin and all of that. So and when that's the case, it is about willpower. But in the last week, I've had the lowest appetite that I've ever had. And that's, that was a massive shock for me. I've never experienced this before.
I know. Well, first of all, we can have this discussion, but I'm one of those people who genuinely believes calorie counting for weight loss is probably like, it's doomed to fail. I do not think you can outwill yourself. And we can talk about all the reasons why calories in and calories out is a completely broken model practically. Theoretically, it makes sense. Laws of physics do apply. Energy must be conserved, but practically over the long term, it always will fail. Almost always, I would say. I would say 99% of time. So when people fail, it's not a failure of yourself. What you need to do is address metabolism, and low-carb diets help do that in a crazy way. And then one of the reasons I got interested in them metabolically is exactly what you described. And also the fact that when I started it, the last thing I wanted to do was lose weight, but I lost weight, and I couldn't stop it. I couldn't stop losing weight despite eating a crazy amount of calories. And I actually got screening for malabsorption, and I wasn't malabsorbing. And now I'm eating you can look at me, if people watching the video, I'm pretty small. And my body mass index is 20.5 or something. And I'm 5'7". I'm eating around 4,500 calories a day. If I go below 3,200, I'll lose weight. And I work out an hour a day, no cardio. My case might be a little bit more extreme, but I used to do marathon running and have to eat maybe 4,000 or less calories. I do a lot less activity now, but the rules, how do I say this concisely? I would say that energy balance, calories in, calories out, is downstream of proper metabolic function. If your metabolism is working properly, your body and you're eating a real human diet, not processed foods that are going to hijack your brain, then what's going to happen is your body is going to auto-regulate energy balance. So, if you eat too much, your appetite's going to go down, your energy expenditure is going to go up. If you eat too little, the reverse is going to happen. You're going to get an obesogenic microbiome fingerprint, your energy levels are going to go down, your non-exercise activity thermogenesis is going to go down, and you're going to get hungry. And your metabolism is going to change to help promote fat storage. That's why things like The Biggest Loser never have reunions, because they always gain the weight back. In fact, they gain the weight back. But while they're gaining the weight back, their metabolism continues to be damaged. They did a basal metabolic rate study on the Biggest Loser participants. They found that after the trial, I think that their basal metabolic rate had decreased 500 calories per day, their basal metabolic rate. And then, 6 years later, they had recovered 70% of the weight, but their basal metabolic rate was then 700 calories below baseline. It just persisted. And you can recover this, but chronic caloric restriction, it's doomed to fail. In fact, I work as a metabolic health coach, and the only time I'm working with people where I tell them to track calories, literally the only time, is when I suspect they're eating too few calories, and inevitably I'm right, and we have to bring their calories up, and then they can lose weight. So if somebody's not losing weight, I'm like, all right, I want you to track calories for a little while. They're usually eating between 1,100 and 1,300 calories. And then we were able to titrate it up through increasing protein and fat, depending on where they're at, to something a little bit more appropriate. And generally they have first an increase in lean body mass, and then an improvement in body composition and a decrease in fat mass. And overall, they end up at a lower weight point than they were before, despite exercising the same, and despite eating more. So I think calories in, calories out it's a harmful model, because it causes people to feel like they're failing, and it leads to fat shaming, because the only conclusion, if eat less, move more works, is that you're not doing it right. Like, that's the inevitable conclusion that people are going to come to, which is why we need to focus on metabolic health, because I think, once you can get that in order, things fall into place, and then you see these life transformations of people that were never able to maintain their weight doing it without effort. And I really mean that. Like, the initial lifestyle intervention, the switch takes effort. But once you're there and you're auto-regulating, you actually can eat intuitively, which is not an easy thing to do, because if you're addicted to carbohydrates and sugars, you just can't. It's not eating intuitively to say, I crave an Oreo, therefore I eat an Oreo. Eating intuitively means actually being able to listen to the signals that your body wants for nutrients, and if that's obscured by poor metabolic health and a hormonal roller coaster of insulin spiking and dropping, you just can't eat intuitively. But to get to that point and to be healthy and to eat just like any animal does in nature, where they maintain a healthy weight, it's the most liberating thing.
This is incredibly inspiring. Like, I speak to, there are some doctors now who do promote nutrition and lifestyle medicine, but I rarely speak to people, especially people in medicine, who talk about intuition, who talk about listening to your body, experimenting with yourself, figuring out what works for you, and, paying attention.
Yeah.
So it's really incredible to speak to you and hear you talk about diet and lifestyle like this.
Yeah, it's funny, because it's almost a paradox in my personality. I was talking with a friend from Oxford the other day, who's an MD PhD over in Mexico, and we are the two biggest, metabolic and biohacking nerds you can imagine. Like, we would do biopsies on each other basically at Oxford. Like, we want to know every muscle metabolite, whatever's going on, get the CGM, everything, and we love all the data. That said, in being people who are super into data, one thing you come to realize, once you start to you try to biohack again and again and again, is that this is so enormously complex. We will never, ever, ever fully understand it. And so the best thing you can do in the end is kind of listen. Like, every day I'm reading something that just blows my mind about how metabolism works, like bile acids. We think about them as just, they're secreted by your liver, they help you digest fat. Guess what? They go to the brain and they change hormonal, hunger signaling and thyroid hormone function and insulin sensitivity and all these other things. I just thought they were digesting fat. And everything has another purpose that you just don't know or couldn't know until, I don't know, the data comes out in 10 years. And you can track every metabolite and try to make every correlation. And sometimes they're great for inspiring insight and experimentation and hypotheses in yourself. And for me, they're motivating because they enthuse me. But at the end of the day, I found, and my friend finds, and all, I think, extreme biohackers get to that point in their journey where they're like, now I know how to listen to my body. So it's about the journey to figuring out how to do that, because that is the holy grail. But it is a holy grail in that it's really, really hard to find. You can't just be like, I'm going to eat mindfully and then eat intuitively. Those things aren't the same. Eating intuitively is a really difficult place to get to. But if you can get there, it's the best thing.
I totally agree.
And I do think everybody can get there. It's just a hard journey. A long journey. A fun journey.
I realize that I've taken up an hour and a half of your time, over an hour and a half of your time. So I presume you have things to be getting on with, although this conversation could go on forever. I'm having so much fun.
A lot of fun. Yeah, there are a lot of things I know that we could have talked about that we didn't get to talk about. A lot of myths I wanted to bust. We could do tips here and there. any final random things you want me to monologue on? You can tell that I like talking. I do have things to get to, but I don't know.
I'm addicted to learning and talking and information and interesting people. That's my addiction.
And you're really good at communicating it as well. So, I mean, we've derailed massively from a lot of the questions that I wanted to ask, but that's fantastic because
it's like that's why Joe Rogan's
exactly
so popular. That's a life goal eventually to talk to Joe Rogan. I think he's a pretty interesting dude. I definitely do not agree with a lot of his guests or some of the things he says, but I think he's kind of funny. And I love the fact that they tangent. There's real people talking about like whatever. Neil deGrasse Tyson talking about his exercise routine. Like, great. Like, tell me like what.
It's awesome.
Are you into this movie, that movie? Are you gonna go watch Loki tomorrow? I'm a big MCU fan. Anyway, yeah. So.
Well, yeah. As I said, there's a lot more we could dive into. Maybe we need to do a part 2.
All right. Well, thank you so much for having me. And yeah, people can reach me. I'm not that active on social media, but I'm on Twitter at Nick Norwitz, where I sometimes post random health facts, and I'm pretty responsive. So yeah. No,
You have a YouTube channel as well that you kept quiet.
Oh, I wasn't keeping it.
Should we post the link to that as well?
You can. The YouTube channel is one of those things that if I have a free second of time, which is becoming more and more scarce, I just jump on if I've read an interesting paper like that bile acids one I said, and I'll just nerd out. So if you liked my rants, they didn't bore you to death, then there might be some interesting things for you there periodically. It is not something that I am committed to. But I do have a green screen, which I couldn't use on this platform, unfortunately, so you just get the gross background of my basement wall and a microphone. So now I might just get up, throw some data up there and say, oh, look, there's this new G protein coupled receptor that doesn't need a ligand. Let's talk about it in thermogenesis. So for 10 minutes, if that
sounds like I'm going to be up all night watching your YouTube channel.
It's a very niche thing, and I do it for my pleasure mostly. But if anybody gets a kick out of it, so be it. Yeah.
Well, we'll post all the links to all the studies that we've discussed or that you've brought up as well.
Sure.
And links to contact you as well.
Thanks.
Is there any last messages?
No, it was a great conversation, Ellie. Thank you for having me, and best to everybody on their personal health journey.